So SQL GATE questions. Let's start. So you can take your copy pen so that you can try. Let's start with our first question, question number 1. And this is a very nice analytical question. Let me tell you, this is not a straightforward question. This is purely analytical question. So actually you can think like this. See, in the GATE 2000, in that year, okay, when this question first came, the first time when this question came, at that time this was an analytical question for those students. Yes or no? Those students have to think like what this question is asking. Okay, at that point, okay, in the exam they have to think, they have to analyze this question during the exam. So this is not a complicated question, this is not a hard question, but this is an analytical question. Okay, so let's try this question. So a very nice analytical question this is. Okay, so can you try this? So let's see what this question is saying. So the question is actually very easy. Let's see this. So the question is saying that in SQL, relations can contain null values, and we already know, yes or no? In SQL, relations can contain null values, and comparisons with null values are treated as unknown. This we have already seen. If you do comparison with the null values, then we treat this as unknown. That is by default, correct? So for example, if you have a relation, like if you have a attribute in a relation, if you have some attribute in this relation, if let's assume this is your attribute C, and in this C attribute you can have many values, for example 2 3, okay, 2, and let's assume null. Okay, so like this, if you have, now in this situation what happens, that if you put some condition, for example where, if you put some condition in the SQL that where C is less than I can say C is less than 3, yes or no? So in this situation, which tuple will pass? In this situation, which tuple will pass? So you can notice for this tuple, what will happen for this tuple? Okay, so you can notice for this tuple what will happen for this tuple, for this complete tuple, what will happen? So this will be true for this complete tuple. This condition will be true. This is your condition. This condition will be true for this complete tuple. And next you can notice for this complete tuple, again the condition is false. Okay, the condition is false. For this tuple the condition will be true. For this tuple the condition will be true. But now look at this condition. Now look at this tuple. Okay, so we are saying C less than 3. So it simply means that for this tuple, what we need to do? We need to do this. We need to check this null is less than 3. And you can notice this is a comparison. This is a comparison. You can notice this is a comparison operation. This is a comparison operation. So comparison with null value, that is null or unknown. Comparison with null value, that is a null or unknown. So that is unknown. That is a unknown. So the comparison with null value, that is unknown. That is unknown. So this unknown is another truth value. Yes or no? This is a third truth value. This is a third truth value. This is a third truth value, because you know in SQL you have 3 truth values. Yes or no? In the SQL, how many truth values are there? In the SQL, there are 3 truth values. One is true, one is false, and another is unknown. So this unknown is another truth value. Remember, there is a difference between unknown and null. There is difference between unknown and null, that we already know, that we have already seen. So these things are different. You can notice this is a truth value. Okay, this is a truth value. This is a truth value. Okay, and this is, I can say this is some attribute value. This is basically, I can say this is an attribute value, right? Okay, this is a attribute value. So this is attribute value, and remember, and this is a truth value. So there is a difference between unknown and null. For example, what I want to say is this. For example, if I want to say that C is less than equal, or maybe I can say maybe B is less than C plus 3. Okay, maybe B is less than C plus 3. Now let me give you the B column also. Let me also give you the B column, and I'm saying that B is less than or maybe less than equal to, or not equal to. Okay, or you can put not equal to, that is also comparison, or you can put equal to, so that is also comparison. This is also comparison. So here I'm saying that, for example, if I say Here I put 5, here I put 6, here I put, okay, here I put maybe null, here I put null, and here I put maybe 5, and here I put null. Now what will happen? See, all the possibilities I am taking all the possibilities. Okay, in this situation, what will happen? Now, first of all, a simple thing you tell me. If I have this, okay, which is comparison and which is arithmetic? In this, two operators are there. This is this comparison? Is this a comparison? No, this is not comparison. This is arithmetic operator. This is arithmetic operator. This is not comparison. This is arithmetic operator. And this is comparison. Yes or no? This is comparison operator. So this is a comparison operator. So this is your comparison operation. Now remember, we already know that what this value will be. If I do null plus 3, what this value will be? Null plus 3. This value will be unknown. Can I say this value will be unknown? Can I say this value will be unknown? Or can I say this will be null? Which is correct? Which is correct? Okay, so this is correct, right? Okay, this is correct. And this is wrong. And this is a wrong. Okay, this is a wrong. Right? Okay, yes or no? So this is wrong. Because remember, I told you that if you do null, okay, any arithmetic operation, if you do, arithmetic operation, any arithmetic operation you do, like plus, any arithmetic operation you do, okay, any arithmetic operation, if you do any arithmetic operation, for example, like if you do plus, if you do minus, if you do division, if you do multiplication, okay, with anything, so if you do arithmetic operation with anything, then what you will get? Null arithmetic operation with anything, this can be anything. Here you can put anything, here you can put null or not null, okay, whatever you put. So null arithmetic operation, anything, that is null. And what is that? Null comparison with anything. What is that? Null comparison with anything. Null comparison. Here you put some comparison operation. Here you put some comparison operation. Comparison operation, like this is comparison operation. This is not equal to, this is less than, this is greater than, this is less than equal to, this is greater than equal to. So if you put some comparison operator, okay, here you can put anything. Here you can put anything. The result will be unknown. The result will be a truth value. This is a truth value. Okay, this is a truth value. So I told you these points, I already told you, and these are important. So here you can notice, tell me here, for this row, what will happen? For the first row, what will happen? For the first row, what is going to happen? For the first row, what is going to happen? So for the first row, you can notice, for the first row, this will give me what? For the first row, this will give me 2, right? Okay, this will give me 2. This will give me, for the first row, this will give me 5. This is going to be 5, correct? Okay, so this box is going to be 5. And what this will give me? Finally, what this will give me? B is not equal to 5. B is not equal to 5. 5 is not equal to 5. So this will give me false. Okay, this will give me false. Next, for this row, what will happen? For this row, what is going to happen? For this row, what is going to happen? Again, B not equal to C plus 3. So this C plus 3, what this is going to give me? C plus 3, what this is going to give me? This C plus 3 will give me again 6. See, this C plus 3 will give me 6. And this not equal to, what this will give me? This not equal to. Null is not equal to 6. Null is not equal to 6. This will give me unknown. This will give me unknown, right? So for this tuple, we got the, okay. So this tuple is failing. For this tuple, we got the unknown. For this tuple, we got the unknown. And for the first tuple, we got false. What about this next tuple? What about this next tuple? For this next tuple, you will get true. For this next tuple, you will get true. Okay. For the next tuple, what you will get? For the next tuple. For the next tuple, what will happen? See, this will happen. See, this will happen. This will give me a null, right? Yes or no? Correct? Because null plus 3, this is going to give me null. So this is going to give me null. And now 5 is not equal to null. 5 5 is not equal to null. This is going to give me unknown. So for this tuple also I got unknown, right? For this tuple. And similarly for this tuple also I will get a unknown. Is this clear? So which tuple will, I can say, if I want to print, if I directly want to print from R, select star. So how many tuples will be printed? How many tuples will be printed for this query? For this query, number of tuples in the output. Number of tuples in the output for which you are getting true. For which you are getting true. Only one tuple will be in the output. In the output, you will get those tuples for which the where condition is true. Yes or no? For which the where condition is true, those tuples you will get in the output. For which the where condition must be true. Where condition must be true. Remember, the where condition can be this. This, if you notice this where condition, this where and this condition. Now this condition, if you notice, this can be either true or this can be false or this can be unknown. Okay. In these two cases, we will say that tuple fails. Yes or no? In these two cases, tuple fails. Okay. The tuple that you are checking, that tuple will fail. And for this case, tuple pass. Only for this case, tuple will pass. Okay. Anyway, let's come back to this question. Now the question is saying that this happens. This happens in the normally this happens. The question is saying that normally this happens, that comparison with null is treated as unknown. This we already know. Suppose some assumption he is giving. Suppose all comparisons with null are treated as false. Then which of the following pairs are not equivalent? Then which of the following pairs are not equivalent? Before we solve this question, suppose this assumption is not given. Suppose this assumption is not given. This assumption is not given. Okay, now you tell me which of the following, if this is the question. If this is the question, a very straightforward question. A straightforward question if I give you. In this situation, what will happen? A straightforward question I give you. Okay, so comparison with null is unknown. Now which of them are equivalent? Which of the following pairs are equivalent? So you can notice x equal to 5. Can I say this is equivalent to not equal to C? This is the first. Can I say x equal to 5? Can I say this is equal to not of x equal to 5? Here you have to check how many cases. To check the equivalence, you have to check how many cases. If you want to check the equivalence, are they equivalent or not? If you want to check this equivalence, you have to check 3 cases. Yes or no? What are the 3 cases? If you want to check this equivalence, you have to check 3 cases. 3 cases when x is one case when x is maybe some value. Yes or no? When x is some value, other than 5. Yes or no? When x is some value other than 5. This is your case 1. Agree or not? When x is some value other than 5. X is some value other than 5. X is a value other than 5. Now in this situation, what will happen? If x is a value other than 5, then this will be false. Okay. This will be false. This will be true. This will be false. So in this situation, both are false, false. In this situation, LHS is also false. RHS is also false. Correct? Agree? Okay. What is the second situation? The second situation is when x is a value, some value which is 5. When x is a value which is 5. In this situation, both LHS and RHS will be true. Right? Both LHS, RHS, they will become true. The third situation, when x is a null. The third situation, when x is null. In this situation, what will be LHS? What will be LHS? In this situation, what will be LHS? LHS will be unknown. What will be RHS? RHS will be unknown. What is not of unknown? What is not of unknown? Not of unknown is unknown. Again, not of unknown is unknown. So again, you will get unknown because we already know this. What we know. So these are the 3 cases, right? See, this is how you can solve. Now you can notice this we already know, that what is not of unknown. What is not of unknown? That is a unknown. Okay, because what was trick to remember this? What was a trick to remember this? The trick to remember this was that you consider an unknown as half. You consider true as 1. You consider false as 0. Okay, you consider this false as 0. Then in this situation, not of anything. What is that? Not of anything is equal to 1 minus x. This was the trick, correct? Not of x is equal to 1 minus x. This was the trick to remember. This was the trick to remember, correct? Agree or not? This was the trick to remember, that not of x is equal to 1 minus x. You treat true as 1, false as 0, and unknown as half. Then you can notice this is your trick to remember. So not of unknown is unknown. Not of true is false. Not of false is true. So in this situation, I can say they are equivalent. Agree? So if I ask you this question, then you can notice they are definitely equivalent. Okay. Now what the actual question is saying? Now let's come to the actual question. For the option A, let's come to actual question. For the option A, what the question is saying? The question is saying comparison with null is false. What the question is saying? The question is saying that if you do comparison with null, this comparison with null, you treat as false. Okay, this is assumption. Okay, does it mean, okay, if this assumption is given, then tell me what will be the value of this null plus 3? What will be the value of this? What will be the value of this? That will still be unknown. That will still be null, right? Agree? Because the question is talking about the comparison, not the arithmetic operation. The question is talking about comparison with null. If you do comparison with null, like for example, null is less than 3, this will be treated as false. Okay, and tell me what this will be then what this will be? Here null is less than 3 is this, then what this will become? Null is less than 3 is false. Null less than 3, that is false. Null less than 3, that is false. So what it will become? What it will become? Should it become true? Should it become true? Like null, see, null less than 3, that is, you are saying that is false. So should it become true? Should it become true? No. Remember, this is also comparison. Think like this. This is comparison. So comparison with null is a false. This is also comparison. So this is also unknown. This is also false, because comparison with null is false. Is this clear? Okay, comparison with null is false. So this is the idea. Now, for example, if this will be what? Null equal to 3. Null equal to 3 will be false. So what will be null not equal to 3? What will be null not equal to 3? Null equal to 3 is false. This is comparison. So comparison, the question is saying comparison with null is false. The question is saying comparison with null is false. This is also comparison, right? This is also comparison. So comparison with null is what? So comparison with null is a false. So this is also false. So remember, comparison with null is taken as false. Okay, now let's come back to this question. So in our original question, what will be option A? For the original question, what will be option A? Are they equivalent for the original question? See, these cases, first two cases are same. First two cases you don't have to check. Agree? First two cases you don't have to check. Those are very simple. Okay, true or false. Those are very intuitive. So first two cases you don't have to check. You only have to check the third case. Let me check the third case. Okay, so in this situation, LHS is what? If X is null, then LHS will be unknown. Then LHS will be false. LHS will be false. Okay, only the case 3 matters. Only check this case. Okay, only this case you need to check. only you need to check this case. Okay, so here this comparison will be false. And what will be RHS? See, this comparison will be false, so this will become true, so this will become false. Agree? So this also will become false. So they are equivalent. In all the three cases, they are equivalent, because in RHS, what will become? RHS will be like this: false, not. So that will be false. So you can notice option A, they are equivalent. In this original question, option A, they are equivalent. They are equivalent. The question is asking for not equivalent. The question is asking for not equivalent. So in the equivalent, I can say they are equivalent. Okay, these two are equivalent if this was the question, but in this situation also they are equivalent. What about the option B? What about option B? Option B is saying x equal to 5. Okay, so one is x equal to 5 and another is this. LHS is x equal to 5 and RHS is what? So in the question, the LHS in the second option, what is LHS? LHS is x equal to 5. And what is RHS? Integer value. X is integer. X is integer. RHS is x greater than 4 and x less than 6. Okay, so this is the question. Now, for this question, what will happen? See, okay, verbally you do. If x is 5, then both will be what? If x is 5, then both will be true. Correct? If x is 5, both will be true. So you can clearly see that there are three cases. Remember, actually there are three cases. Okay, actually there are three cases. There one case is if x is 5, one case if x is not 5, and one case is if x is null. Okay, one case where x is 5. In this situation, LHS, RHS, they both will become true. Okay, RHS and LHS, they will both become true. If x is not equal to 5, like maybe x is equal to 6. Okay, if x is not equal to 5, maybe x is equal to 6. If x is equal to 6, then in this situation, both LHS and RHS, they will become false. Okay, can I guarantee RHS will be false? Can I guarantee RHS will be false if x is not equal to 5? What about 4.5? What about 4.5? This is true, this is true. What about 4.5? What about 4.5? The question is saying that integer. The question is already saying that x is integer. This information is given in the question. Okay, now finally, this is the case that matters. Actually, this case matters. You only have to check this case that matters. So you only have to check this case. In this case, what will be LHS? In this case, comparison false. Comparison false. Okay, what will be RHS? Comparison false and comparison false. False and false, that is false. So again, they are equivalent, right? So the option 2, again, they are equivalent. What about option 3? Option C. Let's see option C. Let's see option 3. In the option 3, what is LHS? The LHS is x is not equal to 5. This is LHS. Okay, x is not equal to 5. And what is RHS? RHS is not of x equal to 5. Not of x equal to 5. Okay, you can notice in this situation, if x is null, this case matters, right? Okay, this case actually matters. The remaining two cases, okay, verbally check. The remaining two cases verbally check. Like if x is 5, then this will be false and this will be false. If x is 6, then this will be true. This will be true. So only this case matters. The remaining two cases you have to check or can you skip? The remaining two cases, do you have to check or can you skip? You have to check, but you verbally check. Yuvraj, if you skip, maybe some question, so in some other question, maybe they can create something else. See, they are gate people. They are gate professors. They can do anything. They can give you some random, like comparison with this is this. Okay, something they can give. Yes or no? Okay, so just to be, I can say safe, just to be safe, you should read the question. Okay, just to be safe, you read the question and you find out whether true comma false will matter or not. Yes or no? In the question you check, like in this question you already know that the remaining two cases will not matter. The remaining two cases where x is not null, where x is 5, x is 6, x is 7, x is 8. Okay, if x is some value, okay, if x is some integer value, then those cases will not matter. In this question those will not matter, but in some other question they might matter. I don't know, they may or may not matter. Yes or no? They may or may not matter. Okay, so this is the idea. So you can notice, verbally you can check that if x is 5, this will be false. If x is 5, then this will be true, not of true will be false. So you can notice, if x is 5, this will be false, this will be false. If x is true, if x is 6, then this will be false. Sorry, if x is 6, this will be true. If x is 6, this will be true. Okay, so you can notice this case matters. If x is null, then LHS will be what? If x is null, this is a comparison, so this will be false. Okay, what will be RHS? This is a comparison, so it will be like false, not a false equal to true. So you can notice they are not equivalent. They are not equivalent. So this is the trick in this question. The question is asking which are not equivalent. The answer will be option C. The answer will be option C. Okay, is this clear to everyone? The question is clear. And if the question is like this, if the question was original question, comparison, if the question was original question, like comparison with the null is unknown. If the question has no trick, then in this situation, they all are equivalent. Okay, let's check the option C. Will it be equivalent? If x is null, then what LHS will become? This comparison will become unknown. And what RHS will become? This comparison will become unknown. Not of unknown will be unknown. So you can notice they are also equivalent. So all will be equivalent. In this situation, all will be equivalent. Okay. In this situation, all of them will become equivalent. Okay. The question can also ask you some other thing. What else can the question ask you? What else the question? Okay, so like, will it matter if I change this false to true? If the comparison with unknown, if I make it true, if I make this comparison true, comparison with unknown, if I make true, means if I make this variation, that comparison with unknown is true. If I make comparison with unknown true, like if you do comparison with unknown, I make it true. In this situation also, you can notice, let's see the option A. Okay, so comparison with that will be true. Okay, right, comparison. If x is null, just check where x is null. So if x is null, then this comparison will become true. This will become true, this will become false, this will become true. So they are equivalent. Okay, so they are definitely equivalent. And in this situation, the question is asking not equivalent. So again, if null you have, then this comparison will become true. Okay, this comparison will become true, this comparison will become true. So ultimately this is the, okay, next you can notice, again the answer will be this, because in this again the same thing will happen. If x is null, then what will happen? Then LHS will be what? If x is null, the LHS is a comparison. So LHS will become true. And what RHS will become? RHS will become not of true. The RHS will become not of true. So again, they are not equivalent. So some variations, okay, like this maybe some variations you can create. Okay, so this is the complete analysis of this question. But did you notice one thing? This question tells you a lot about GATE exam. What this question tells you? This question tells you about GATE exam. What GATE exam is all about? GATE exam is a very simple exam. Okay, but see, the difference between problem solving, if you have good problem solving skills, and if you have knowledge, like if you remember the facts, if you know all the facts, like in all the subjects, all the facts you have, okay, you know everything, comparison with null is unknown, you know everything which is in your notes. Okay, you have almost 10-12 subjects, 10 or 11 subjects are there. In those subjects, in your notes, whatever is there, if you already know, then also this question needs what? Then also this question cannot be solved. This question is very easy, but it can only be solved with analysis, with your problem solving skills. And remember one more thing, in the GATE exam, you don't have a lot of time. You have only 2 minutes, 3 minutes for one question. Yes or no? Either 2 or 3 minutes for one question. In those 2-3 minutes, you have to think about this question, what the question is asking. Okay, then you have to check each option. So remember, GATE exam is all about this type of questions. This type of questions make GATE exam very good exam. Okay, because in the GATE exam, those students will top, those students will succeed whose problem solving skills, whose analytical skills are very good. Okay, is this clear? Okay, anyway, so that is the reason you should do complete analysis. That is the reason you should do complete analysis. Okay, whatever question you solve, whatever GATE question you solve, okay, you should do complete analysis. Because if you only get the answer, if you get the answer and you move on, then what will happen? Okay, then you have not used your brain completely for that question. For that question, you do the complete analysis, so that if some question comes, okay, which is related to that question, then you can solve it. Okay, let's move on. This is very simple question. Tell me, GATE 1999, which of the following is or are correct? So this is a MSQ question. Is or are correct? An SQL query automatically eliminates duplicates. SQL does not eliminate duplicate by default. Yes or no? So by default, it does not do that. Yes or no? By default, duplicates are not eliminated. Okay, let's see option number B. An SQL query will not work if there are no indexes on the relations. Tell me, when you study SQL, do you care about indexes? Just tell me, very simple thing. When you study SQL, at that time, do you care about indexes? Do you care how data is stored? Tell me, when you study SQL, do you care about which data structure we are using to store the database? Okay, to store the database, which data structure we are using, which indexes we have created. Okay, so these things we don't care when we study SQL, right? Okay, these things actually do not matter. For the SQL query, these things do not matter. Of course, these things, they can affect the performance. Okay, these things can definitely affect the performance. Okay, if you have an index, just think about it. You read a book. In that book, if index is there, then definitely you can very quickly you can find the data. Very quickly you can find the related data, the relevant data, what desired data. So if you have indexes, then some efficiency will change. Efficiency will definitely change. If you have more indexes, okay, then efficiency will be more. If you don't have any index, then efficiency will be less. Okay, you will take more time. Your SQL query will take 10 minutes. And if you have indexes, your SQL query will take 1 minute. Efficiency will change if you have indexes. Efficiency will change depending on the data structure that you are using to store the database. Your database you are storing. Okay, so to store the database, which data structure you are using? B tree, B plus tree. Okay, we will study all these concepts, but you can notice, so performance will change, performance will be affected, but you can notice the query, the SQL query, okay, that will still work. That will still work. So this statement is definitely false. Okay, SQL permits attribute names to be repeated in the same relation. Can attribute names can be same? Attribute names, can they be same? They can never be same. Okay, they can never be same. So okay, so finally, actually, none of these is correct. So remember, attribute names cannot be same. In the same relation, attribute names can never be same. Okay, in the same relation, the SQL, whether it is SQL or it is relational algebra, whatever you take, actually, they will never be same. Remember, they will never be same. In the same relation, okay, attribute names can never be same. Whether you take SQL, whether you take relational algebra, whether you take relational calculus, whatever you take, in the same relation, attribute names must be different. Attribute names must be different in the same relation. Must be different. If they are same, there will be the ambiguity. If they are same, if attributes are repeated, if attribute names are repeated, then that will become very much ambiguous. Then that will become very much ambiguous. Okay, so if this happens, if then this will happen, then ambiguity will be there. So anyway, answer will be option D. None of these is correct. Okay, so tell me this one. This is a GATE 2000 question. Given relation wx yz, the result of this, what does this is saying? This is a very nice question. This is a very nice question. Okay, let's see this. So from r comma s, you are distinct w comma x. Again, you are selecting w comma x. Okay. So first of all, you are using distinct. Okay, so we will create one variation where you don't have distinct, right? So that variation also we will create. Okay, so for complete analysis, we will create that variation also. But here, what this is doing, you are selecting distinct w comma x. First of all, you tell me, can R have, okay, without checking anything, you tell me, in this, can you have duplicate pairs? In this, can you have duplicate tuples? Without checking anything, this output, can it have duplicate tuples? There is distinct word, so it cannot have duplicate tuples, right? It cannot have duplicate tuples. This you can guarantee, right? Agree or not? This you can guarantee by this word select distinct. This you can guarantee that this cannot have duplicate tuples. The original R, can it have duplicate tuples? The original R, can it have duplicate tuples? Can it have the original R? Can it have duplicate tuples? Can have duplicate tuples, right? Can have duplicate tuples. Can have duplicate tuples. Agree? It can have duplicate tuples. So which option is gone? Is guaranteed to be same as R. Is guaranteed to be same as R. Okay, so anyway, okay, before that. Okay, anyway, this is the first point. See, this is the first point. Is this clear? This is the first point. The first point you have to remember that R can have duplicate tuples, but the result, it can never have duplicate tuples. Now the second point. The second point is this. If you notice what this is doing, ultimately you are doing the cross product. What is the conceptual evaluation? For this, what is the conceptual evaluation? Just tell me that point. What is the conceptual evaluation? The conceptual evaluation, first you are doing the cross product. So every tuple will match with every tuple. Okay, first you are doing the cross product. Every tuple will match with every tuple. Then you are selecting wx. Then you are basically filtering. Then you are basically projecting what? Then you are basically projecting this R again. Then you are basically projecting R again. Okay. Then you are basically projecting R again, and then duplicates will be removed. Then duplicates will be removed because you are saying that it is distinct. Because it is a distinct word, so duplicates will be removed. Okay. Now, in this situation, finally, what can happen if you don't have this distinct word? If this distinct word is not there, then you can have more tuples here, right? Okay, let's see one example like RWX. If you have like 1, 2, and let's assume 2, 3. Okay, and you have S. In the S, you have what? In the S, you have YZ. In the S, let's assume you have A, B, and CD. So in the cross product, if I write this query, how many tuples will be there? If I write this query, select W comma X from R comma S. Tell me number of tuples. In this situation, tell me number of tuples. Tell me number of tuples. In this situation, tell me number of tuples. If I don't have any distinct, I will have total 4 tuples. And those 4 tuples will be like this. Yes or no? 1, 2, 1, 2, 2, 3, 2, 3. Agree? Correct? So you can notice this repetition will happen. This repetition will happen. If I don't use the distinct word, this repetition is happening. if I don't use the distinct word. But in the same question, if I use the distinct word, now what will be the number of tuples? Now the number of tuples will be only 2. Now the number of tuples will be only 2. 1, 2, 2, 3. Okay, now this will be the number of tuples. You can notice one thing. What you can guarantee? This query will definitely, if you look at this query, whatever r comma s you take, what you can guarantee with this query? With this query, you can guarantee what? This query can guarantee what? This query can guarantee superset of R. Okay, with duplication. What you can guarantee with this query? With this query, you can guarantee that, okay, the output will be superset of R. Okay, every tuple of R will be there. See, every tuple of R will be there. Every tuple of R will be there. But they can be duplicated. Yes or no? They can be duplicated. See, what I can say, you can guarantee that, okay, output contains every tuple of R. Output contains every tuple of R. Every tuple of R. But possible duplication. But possibly duplication can happen. Correct? Okay, possibly duplicates can be there. They may or may not be there. Yes or no? They may or may not be there. For example, if you have single tuple, here single tuple, here single tuple, then there will be no duplicates. Okay, so this you can guarantee with this, that output contains every tuple of R. Output contains every tuple of R. And actually, this can only happen with what? If S is 5, then what will happen? If S is 5, if S is empty, now what will happen? Tell me, if S is empty, here if I give you that S is empty, and let's assume R is not empty. If I give you this, okay, if S is empty and R is not empty, then in this situation, what will be the output? In this situation, what will be the output? If S is empty, your S is empty. So in this situation, this cross product will be empty. Correct? So in this situation, this cross product will be empty. So when you select, you will get empty. So your output will be what? Your output will be empty. So your output, you can never get R back. Yes or no? So in this situation, R output is not equal to R. In this situation. Okay. So I can guarantee, I can say that if S is not 5, right? S must not be 5. S must not be 5. Then I can say this. Correct? Okay, S must not be 5. S must not be 5. This S must not be 5. Then I can say that output will contain every tuple of R, but possible duplication can be there. Now, that possible duplication I can remove with the distinct keyword. Correct? With the distinct word, the output cannot have duplicates. So output will contain every tuple of R. Output will contain every tuple of R, but no duplicate. Now who is superset of whom? Now who is superset of whom? Now who is superset of whom? Output contain every tuple of R, but no duplicates. Now, can I say output is same as R? Can I say output is same as R? Now R is superset of output. Remember, because R can have duplicates. Because R can have duplicates. Is this clear? But R can have duplicates. R can have duplicates. Okay. So R can have duplicates. So in which situation they will be exactly equal? In which situation they will be exactly equal? In which situation can you say that they will be exactly equal? When R has no duplicate, right? When R has no duplicate and S is not 5. S is not 5. Okay, now they will be same. If R has no duplicate. If S is 5 and R has no duplicate. R has no duplicate. Okay, then they will be in this situation. If R has no duplicate and S is not 5, then you can guarantee they will be exactly same. See, in this question total, all the variations I have taken. Yes or no? See, all the variations I have taken. Yeah, this distinct word is there. This distinct word is already given. See, all the variations I have taken. Like if only this happens, then what? See, now, is this clear to everyone? Please tell me. Is this clear? See, that one by one, I have told you everything. Let's come back to the question. Let's come back to our question. So in this question, now let's see each option. Look at each option. If R, S have no duplicates, if R, S have no duplicate, then why this is not correct? First of all, we don't care about R. First of all, we don't care about S. Yes or no? We don't really care about S. S can have duplicates, right? S can have duplicates. So we don't really care about S. S must be non-empty. So basically, on S, what are the conditions? On S, what are the conditions? On S, what are the conditions? The only condition is not empty. On S, the only condition is not empty. Is not empty. This is the only condition. Duplicates may or may not be there. S may or may not have duplicates. Yes or no? S may or may not have duplicates. May not have duplicates. You may or may not have duplicates. So on S, we only have one condition, that is not empty. Okay. So definitely I can say that this is the only condition. So this condition, can it guarantee? If they have no duplicates, this condition cannot guarantee, because S can be 5. This condition, remember, this is one way. Remember, this is one way. This is one way. Like this option, does it imply this option? This option, does it imply this option? This option, does it imply this option? The question. So this is not correct, because S may be empty. Okay, so you cannot, this option is wrong. Why? What is the reason for this option to be wrong? Because S may be empty. This option is wrong because S may be empty. So that is the reason this option is wrong, because S may be empty. Okay, what about this? Have same number of tuples. Okay, this does not guarantee anything. Yes or no? This does not guarantee anything. So this is also wrong. This does not guarantee anything. If they have same number of tuples, this does not guarantee anything. S has no duplicates. We don't care about S. We don't care about S. R has no duplicates and S is non-empty. This is correct. So option A is correct. Is this clear? So option A is correct. This is correct. Okay. And if I don't have this distinct word, if I remove this distinct word, now which option I should make? Now when can I guarantee that they will be same? If I remove the this distinct word, now in which situation I can guarantee they will be same? In which situation I can guarantee they will be same? In which situation I can guarantee that they will be same? If I don't use the distinct word. Now, if I don't use the distinct word, now S should have single tuple, right? Yes or no? S should have single tuple. S must have single tuple, right? S must have single tuple. One tuple. S must have single tuple. Okay, S must have single tuple. If S has more than one tuple, then they will not be same. If S has more than, if S is empty, then also they will not be same. S should have one tuple, or R should be empty, S should be empty, or R should be empty, or I can say or R should be empty. Yes or no? Or R should be empty. Either R should be empty, or S must have single tuple. If R is not empty, then S must have single tuple. Do you agree? Yes or no? If R is not empty, if R has at least one tuple, then S must have single tuple. Correct? So this is your answer for this question. Okay, for this variation, this is the answer. That either you have this. So for this question, answer will be either you this or this. Okay, either this or this. So for this question, the answer will be, I can say either R is empty or S cardinality equal to 1. S cardinality equal to 1. S has only one tuple. See, if S has only one tuple and if R has repetition, just think about it. If let's assume R has repetition, but S has only one tuple, then also they will be same. They will be guaranteed that they will be same. Correct? They will be same. There is a guarantee. So for this question, answer will be this. Okay, like this, you can do some variations. This is the complete analysis of this question. Now let's move on. Let's see this question. Can you solve it? GATE 2003 question. Is it visible? The question visible, right? Okay. Okay, let's see this. So first of all, this database is given to you. This database is given to you. Okay. And the question is talking about something else. A query is given to you. First of all, look at this query. Is this nested query? Is this nested query? This query, is this nested query? This is not a nested query. This is a very simple query. Okay. Direct query. Okay. This is not a nested query. This is actually a direct query. What we are doing the cross product. See, we are doing the cross product of all these three tables. We are doing the cross product. In the cross product, 4 conditions are given. In the cross product, 4 conditions are given. And then we are finding the names. We are finding the names. Name is only here. So student name we are finding. Okay. In the cross product, 4 conditions are given. So first of all, the cross product. The question is saying that cross product is given. Like you have a student table, you have course table, and you have grade table. There are 3 tables. Okay. You can solve the question like this. So first of all, the cross product is given. In the cross product, student, course, and grade. Okay, here what he is saying, student roll number is equal to grade roll number. This is saying that here you have roll number, right? Here you have a roll number. And in the grade also you have a roll number. In the grade also you have a roll number. In the grade also you have a roll number. So here roll number, and you can notice in the grade also you have a roll number. And the question is saying that this must be same as this. Okay, means for the same roll number. For the same roll number, this must be same as this. They must be equal. Like if the roll number is, let's assume 100, then this same roll number 100 here. Okay, next what? Next what is the condition? And. There are and. Course instructor must be Korth. Okay, so in the course table there is instructor in the course table. So that faculty, that instructor must be Korth. That must be Korth. Okay, what else? Course number must be grade course number. Here also you have course number. Here also you have course number. They must be same. Okay. So the course number here, and the course number here, they must be same. Like if the course number is C1, here also the course number must be C1. Okay. Next, grade must be A. This grade must be A. Did you notice you don't have to write grades.grade? Yes or no? Did you notice you don't have to write grades.grade? You can simply write grade because this grade is only in one table. So this grade is equal to A. And this grade, in this grades table, there is a grade and their grade must be A. Okay, that's it. So what it looks like. And finally, we are giving these names in the output. Finally, we are giving these names in the output. So when the name will come in the output, this name, okay, let me give a name. This name will come in the output. This zone will come in the output. If this zone has gotten grade A in this course by Korth, this zone will come in the output. This zone will come in the output. If this zone has gotten grade A in some course by Korth, yes or no? We don't care about all the courses by Korth. Agree? We only care about one. One tuple is enough. See, if you want zone in the output, then one tuple is enough. Agree? If you want zone in the output, then one tuple is enough. In the output, okay, one tuple is enough. One tuple is enough. One tuple is enough. Agree? One tuple is enough. This zone does not have to take all the Korth courses. See, Korth can have many courses. Okay, maybe Korth has many courses. For example, okay, this Korth has many, maybe this Korth can have many courses. This Korth can teach DBMS also. This Korth can teach this C1 also. This Korth can teach maybe CO also. This Korth can have many courses. Remember, this Korth can have many courses. Okay, but if you want zone in the output, what do you need? If you want zone in the output, then what should happen? In this cross product, in this student cross Korth grade, in this cross product, a single tuple should be there. One tuple is enough. Yes or no? One tuple is enough. Correct? Agree? One tuple enough. If you want zone in the output, this is your target. You want zone to be in the output. So if you want zone to be in the output, then what should happen? This zone should have roll number 100. One tuple is enough where all the conditions are satisfied. See, this is what I'm saying again and again. One tuple is enough which satisfied all the conditions. One tuple is enough which satisfies all conditions. One tuple is enough which satisfies all the conditions. This is what I'm saying. So if you want zone in the output, then one tuple is enough. One tuple is enough. This one tuple in the cross product, this is enough where all the conditions are satisfied. Like zone roll number is 100 and this 100 roll number has gotten the grade A in the course C1, where this C1 course is taught by, Korth. So this single tuple is enough. This is what I'm saying. One tuple is enough where all conditions are satisfied. If this type of tuple you have, then zone will be in the output. Now it can happen. See, this tuple, can I say if this tuple is also there, can I say zone will not be in the output? If this tuple is also there, for example, let's assume in the DBMS taught by Korth, let's assume zone has got grade C. Zone has got grade C. Okay, zone has got grade C in the DBMS. So can I say zone will be in the output or not? These two things you have. Zone will be in the output or not? These two things you have. Zone will be in the output or not? Very simple question. So zone got grade. This zone, he got grade C in the DBMS. He got grade A in the C1. So still he will be in the output. Yes or no? So because the where clause, so this will still be in the output. The reason is very simple. Because the where clause will take select tuple by tuple. This you already know. This where clause. Look at this where clause. It checks tuple by tuple. It checks tuple by tuple independently. Okay. The tuple by tuple it will check independently. So one tuple must be enough. So I can say there should be a name of those students who got grade A in at least one courses taught by Korth. This is your answer. Yes or no? We don't need all the courses by Korth. Yes or no? We don't need all courses grade. We don't need grade A in all the courses. Is this clear? We don't need grade A in all the courses by Korth. We don't need grade A in all the courses. Okay. So we don't need that. We only need that those students who got grade A in at least one courses which is taught by Korth. Now let's move on now. So let's see this question. Tell me the answer for this. The employee information in a company is stored. So this employee information is given to you, name, sex, salary, department name. And this query is given to you. First of all, you tell me, this query, is this nested query? Is this nested query? This is not a nested query. This is a very simple direct query. Okay. So this is a direct query. In this query, what the question is saying? First of all, you are selecting male people. First of all, you are selecting male people. Okay. I am selecting directly because this will happen, right? From the employee table, this is the first. The second is this. So first I will select all the male people. Now I will do group by department name. Okay, so what this will do, this is the third step, right? This is the third step. So when you do this, then what will happen? When you do this, only male people you have. So when you do this, then what will happen? Then this, for example, maybe department D1, D1. Okay, department D1, D1. Department D1, D1. And only male people you have, remember. Only male people you have. Male, male. Okay, so those people will come. So like this, like this, virtual partition will happen. Okay, yes or no? Virtual partition will happen like D2, D2. Okay, maybe another D2, maybe another D2. Male, male, male. So like this virtual partition will happen when you do this group by. No, this is not nested query. Okay, okay. So here you have a nested query. Yeah, right, right. Okay, this is a nested query. Actually, yeah, this is a nested query. So you can notice this is actually a nested query because we have here. So this is actually nested query, but in the having clause we have this. Yes or no? So this is a simple subquery. This is correlated or simple? This is correlated or simple? Tell me, this is correlated or simple? This is simple, right? This is simple. Okay, so this is simple. What this simple query, what this does? What this simple query does? Select average salary from employee. So this basically gives you average salary of all employees, or okay, remember, first of all, remember, this is going to give you what? This is a simple query. So its existence without this, it can exist without this, agree? It can exist without this. Without this, it can exist. This is a simple query. This is a simple query. So you can think about it. This is a nested query. So this is an example of this. This is a nested query. Remember, this is a nested query. Okay, where the subquery is simple. Where the subquery is simple. Your subquery is simple. So whenever you have simple subquery, in that situation, you can remove the outer table. In that situation, you can remove the outer table. Okay, forget about the outer table. Forget about the outer table. Just focus on this. Forget about the outer table. Focus on this. So this is giving you average salary of all employee, all male or all. Tell me, this is giving you average salary of all people or all the male people. This is giving you average salary of all employee or all the male employee. Is this giving you all male employee average salary or all employee average salary? This is giving you what? This is giving you all employee average salary. Because remember, this is a subquery which is independent. Yes or no? This is a simple subquery which is completely independent. Which is completely independent. So this is giving you average salary of all employees. All employees, including females. Including females. So this is giving you average salary of all employees. Is this clear? All the employees average salary you are getting. And then finally, this filters the group. Yes or no? This having will filter the group. Why we use this having word? This having is used to filter the groups. So finally, you can notice here, this having will do the filtering. Okay, now this having will do the filtering the groups. So which group will be in the output? Which group will satisfy? So those groups will satisfy where within the group average salary. Remember, this will happen within the group, correct? Yes or no? Yes or no? This will happen within the group. Within the group. Within group. Because having clause applies when? For group by group. Yes or no? This having clause, if you notice this having clause, okay, whatever condition is there, this condition is checked. This condition is checked group by group. This condition is checked group by group, independently. Independently, for every group you will check. Remember, this condition you will check for every group. For every group you are going to check this. For every group you are going to check this. So when you check this for every group, then this is the within the group, what is the average salary, right? Within group, what is the average salary? So this is giving you within group. Within a group, what is the average salary? So I can say that those groups will satisfy. Those groups will satisfy whose average salary is more than those groups will satisfy whose average salary is more than the average salary of all the people. Like if you find average salary of all the people in this table, so finally I can say ultimately what it will give me, ultimately it will give me those department names. Ultimately this will give me this. Okay, so this will be the fifth. So ultimately I will get those department names. I will get department names. Remember, it will return the name of department in which what will happen, the average salary of male people, the average salary of male people is more than the average salary of in the same department. Do we care about the same department? No, we don't care about the same department. The average salary must be greater than all male employee. Again, no. So the average salary is more than the average salary in the company. The average, yeah, option D is correct. Option D is correct because the average salary of male employees must be more than the average salary in the company. Okay, so this is a query. This is a simple query, but here one thing you need to take care. Few things you need to take care. Again, I am telling you, few things you need to take care. See, this is a simple query, so this will happen. This will happen independently. Yes or no? This will happen independent of the outer query. This will happen independent of the outer query. This is the first point you need to notice. This is the first point you need to notice, that this is a simple subquery. This is a simple subquery. And because this is a simple subquery, so this will happen. This is completely independent of the outer query. This is completely independent of outer query. This is purely independent of outer query. Okay, you execute it once. Okay, you can execute it once initially. So this is completely independent of the outer query. Completely independent. So first you can execute this. Is this clear? So this is the first point. You can execute this first. You can execute this first. So first you execute this and done with. Okay, then you can remove it. Then the second point that you have to remember is this having clause. This average salary is what? So remember here the average salary that you are getting. Okay, what I'm saying one by one, these points are important. One by one I am telling you. So here, if you see in this subquery, the average salary that you are getting, that is the average salary of all the people. Yes or no? So here, this average salary that you are getting, this average salary that you are getting here, this is the average salary of all employees of whole company. Yes or no? This is the average salary of whole company. This is the first thing you should notice. And the second point, if you look at this average salary, this is average salary of what? This average salary, this is average salary of groups. Okay, yes or no? I can say this is average salary of within a group. This is average salary within a group, within every group. This is average salary within every group. So this is average salary within every group. Is this clear? And remember, this where will happen first. This will happen very initially. Okay, so this will happen before groups are created. Before groups are created. So this before groups are created, you will get this where will happen. So in all the groups, you will have only males. If you look at all the groups, you will have only males in all the groups. Is this clear? So only groups of male will be there. So that is the reason finally you can notice within group it will happen. So here, because every group contains male only, so you can see that this will happen. Because every group contains male only, so this average salary, this is the average salary of male people in every department. Okay, so these small points you have to take care. Very small points, but you have to take care. Okay, because having clause that applies group by group. Okay, so that will happen for every group. That will execute for every group. That will check every group. Okay, let's see this one. Let's see this question. What is the answer? This is a very simple question actually. So the question is saying select y from t where x is equal to 7. This is the query. Select y from t where x is equal to 7. And the question is saying consider a database table T containing two columns x, y, each of type integer. Okay, so you have a table T. See this question. You have a table T in which you have x, y, both are integers. After the creation of table, you have created the table. Okay, you have created the table. So initially, when you create the table is empty. Initially, when you create the table is empty, right? So after the creation of table, one record is inserted. Okay, we insert one record. This record we insert one. Now what we do? Mx, my, these are the maximum value of x and maximum value of y among all the records in the table at any point of time. Okay, at any point of time. Using mx, my, new records are inserted in the table 128 times. So you will insert new records in the table now. Now you will record new records 128. Tell me. These 128 records that you are inserting, do they contain this initial record? Do they contain this initial record? These 120 record that you are inserting, do they contain the initial record? So it means if they contain the initial record, it means new record are only 127, right? If they contain the initial record, then the new record is only 127. The question is saying new records are inserted 128 times. Okay, is this clear? So after this 128 times record, after this 128 records are inserted. Is this clear? Because the question is saying that new records are inserted. Is this clear? Is this clear to everyone? See, read the question. Is this clear? So because you are inserting new records with the help of mx, my, 128 times new records you are inserting. And what this is saying, the new record has this value, mx plus 1 to my plus 1. It may be noted that after each insertion, these values will change. Of course, the maximum value will change. And then you are putting this query. Okay. So what will be the output of this query? The query is this query is interested in what? The query is interested in where x is equal to 7 in this tuple. Yes or no? The query wants when x is 7, then what is y? This value, what is the answer? Agree or not? Look at this query. Where x is equal to 7. So when x is equal to 7, then what is the y value? Okay, this is what the question is asking. So let's see. Tell me, the new record that you are inserting, what is that? The new record that you are inserting, what is that? The new record that you are inserting, that is mx plus 1. So this you are increasing by 1. And 2my plus 1. See, this you will increase by 1. So this will be 2. And this you will double plus 1. This will be double plus 1. So that will be 3. Yes or no? Next, now. So in this situation, what is mx? The mx was 1, my was 1. Okay, so that is the reason you inserted this tuple. For this tuple, mx is 2. Now the mx is 2. Actually, the mx is calculated not tuple wise. The mx, my, these are not tuple wise. I can say that so far the mx was this. But now for this table, what is mx, my? Now for this table, what is mx, my? For this table, mx is 2, my is 3. Okay. For this table, mx is 2, my is 3. So you can check. For this table, mx is 2 and my is 3. So what will be the next row? The new record will be. So new record, what that will be? New record will be 2 plus 1, that is 3, and twice plus 1. So that will be 3,7. Okay, so the new record will be 3,7. The next record will be 4, double plus 1, 15. The next record will be 5, double plus 1, 31. Next record will be 6, double plus 1, 63. next record will be 7, double plus 1, okay, double plus 1, that is 127. This is your answer. This is your answer. Is this clear? Okay, so your answer is 127. But if the question is asking what will be the answer for this value, if I change the question and what will be the answer for this value, like if I select y, from t, where x is equal to, because you are inserting this 128 times, so where x is equal to 120, after some time it will reach 120, right? After some time it will reach 120. So now what will the answer? Now what will the output? In this situation, what will be the output? See, the question is very simple. If you see the pattern, look at the pattern, what is happening here? Okay, just read the question. What is happening here? Every time x is increasing by 1. Every time x is increasing by 1, right? X is increasing by 1. And y is doubling plus 1. Y is doubling plus 1. So it's like this, x comma y. Initially 1, 1. Now this is increasing by 1 only. This is increasing by 1 only. This will increase by 1 only. But this is doubling plus 1. Okay, so initially this is 1. Initially this is 1. Now you will do double plus 1. So that will be 2 plus 1, that will be 3. Okay, so that will be 3. Double plus 1. Correct? Double plus 1. So here you can actually see this, that, and the next time it will be 7. Next time it will be 7. Actually, if you notice, okay, let's consider this. So what is this value? This value is basically 2. This value is same as x, right? See, this value is same as, here I can say that initially was x was 1. Okay, so x is increasing by 1, 1. Now x is only increasing by 1, 1. This value is basically, I can say this is a 2x plus 1, right? Can I say this is 2x plus 1? This is your x. If this is your x, then this is 2x plus 1. But x equal to 2. Okay, this value is x, basically I can say, for in terms of x, what you can write this value? In terms of x, this value will be what? This value will be 2 power x minus 1. 2 power x minus 1. This value is 2 power x minus 1 in terms of x. Okay, in terms of x, this value is 2 power n minus 1. Correct? The reason why this, actually, okay, see, this is the pattern, because here you are looking at the pattern. If you don't look at the pattern, then what is happening? If you don't look at the pattern, don't look at the pattern, okay? Do not look at the pattern. See, if you, this is the method of what? This is the method of pattern recognition, correct? This is the method of pattern recognition, that you are recognizing the pattern. This is the method of pattern recognition. You are recognizing the pattern, that if you, this is 2, this is 3, this is 3, this is 7, this is 4, this is 15. So you are recognizing the pattern. So I can say ultimately, if this is 4, this is 15. So it means this is 2 power 4 minus 1. So that is 2 power x minus 1. So for 5, this value will be 2 power 5 minus 1. So for 120, this value will be 2 power 120 minus 1. Okay, this is the method of pattern recognition, correct? So for this output will be 2 power 120 minus 1. Okay, basically your y value will always be equal to 2 power x minus 1. So it will always happen in your table T, x comma y. If this value at any point of time, if this value is a, then this value will be 2 power a minus 1. Okay, so this is what is happening. This type of rows are there. This type of rows in the table T. So this is the method of pattern recognition. But you can actually see this, another method. Another method is this. This value is 2. Okay, let me like, okay, whatever. 2 plus 1, right? Okay, this value is 2 plus 1. What is this value? What is this value? This value is basically you again multiply by 2. So it will be 2 power, you again multiply by 2. So yes or no? You multiply this by 2 plus 1. Correct? So actually, if you notice, this is like 2 into this plus 1, right? So this will be this value. What will be the next value? The next value will be you multiply this with 2, then plus 1. You multiply this with 2. You multiply this with 2. You multiply this with 2. You multiply this with 2 and plus 1 extra. You multiply this with 2 and plus 1 extra. Similarly, the next value, what the next value will be? The next value will be you multiply this with 2. You multiply this with 2. Okay, you multiply this with 2. So you multiply this with 2 and plus 1 extra. So this is what is happening here. Yes or no? So if you look at this, so actually it is happening that you multiply this with 2, then you will get 2 power 2 plus 2, and this plus 1 is extra. Okay, so if you notice, there is a, you are getting, tell me, you are getting a GP, right? Yes or no? You are getting a GP. And can you notice what is the number of terms? What is the number of terms? Number of terms, number of terms. What is that? Number of terms is equal to value of x. Number of terms is equal to value of x. Yes or no? Number of terms is equal to value of x. Is this clear? You are getting a GP. If you do like this, you are getting a GP. And number of terms, here number of terms is 5. Here number of terms is 4. Here number of terms is 4, which is x. Because x is increasing 1 by 1. Because x is increasing 1 by 1. So finally from here, what I can say? Finally, okay, you are getting this. So if your x comma y, so this is what you are getting. If this value is a, then what this value will be? This value will be series. Okay, this value will be a series. 1 plus 2 square plus 2 cube. This will be a series. How many terms? How many total terms? What is the number of terms? Number of terms is a. So finally you will get 2 power a minus 1 because number of terms is a. Remember this 2, this 1 you can write as 2 power 0. This you can write as 2 power 0. So you can notice number of terms is a. The last term will be 2 power a minus 1. Now if you do the summation, if you do the summation of this series, what this series will become? If you do the series, this summation, then this is your first term multiplied by common ratio. Here the common ratio is 2. So first term multiplied by common ratio power number of terms minus 1 divided by common ratio minus 1. So answer will be 2 power a minus 1. So this value will be 2 power a minus 1. Both the analysis, are they clear? Tell me. See, this is your pattern recognition. You are recognizing the pattern. This is very good. This is very good. This is short method. Okay, this is method of pattern recognition. And this is a straightforward method, like, okay, how the things are actually happening. Yes or no? Agree? So I can say this is your method 1. You can call it method 1. And you can call it method 2. But of course, in the GATE exam, you should apply this method, of course. Yes or no? This is better. This is more efficient. Pattern recognition is more efficient, correct? And this is another. So anyway, finally, your answer will be this. 127. Now let's move on. In the same question, another variation, what they can ask? Can you notice what is the another variation they can ask? This type of variation also they can ask, like sum of x or sum of y. Sum of x, sum of y. Correct? From t. Yes or no? And if they don't remove the, they remove. Okay, so finally here what will be the output? Here what will be the output? Because remember the question is saying that the question has already given you the information. The question has already given you the information that here total 128 tuples are there. Here 120 more records are there. Okay, so this information is already given in the table. This 2, 3 in the question. Okay, so like and so on. So finally your answer will be what? For this question, what is the answer? This will be what? Sum of x. That is a series, right? That is a series 1 to 129. Okay, so that will be your 1 plus 2 plus and so on 129. This is a AP. This is your AP series. Okay, 1 to n. So that will be n into n plus 1 by 2. So this will be that. Of course, they will not ask you this, but similarly, you can find this because, okay, this is what you know that. So it will be, of course, it will be very complicated. Okay, so what it will be? You will do the summation of all of them. Okay, from x, so basically this you will do from 2 power x minus 1, where x is going from 1 to 129. Correct? Yes or no? This will be the summation 2 power x minus 1. So this will be like, I can say summation of 2 power x minus 129. Okay, minus 129. This you will remove. Minus 129 you will remove. Here x is going from 1 to 129. So this is like 2 power 1 plus 2 power 2 plus 2 power 3 plus 2 power 129. Again, this is a series. Yes or no? Correct? So again, this is a GP. Again, this is a GP. So its answer will be, you can notice, twice multiplied by common ratio, power number of terms, minus 1 divided by 1. Okay, this minus 129. This will be your answer. Is this clear to everyone? Yes or no? X will start from 1, right? X is starting from 1. That's correct. Okay, this is correct. This is correct. Yuvraj, you can check it out. Like this is your 2 power 1 minus 1. This is 2 power 2 minus 1. So finally you will have 129. So that value will be 2 power 129 minus 1. So if you do the summation, that will be 2 power 1 plus 2 power 2 plus 2 power 129 minus 120. So this will be your answer. Is this clear? So what this will be? This will be 2 into 2 power 129 minus 1 minus 129. So like this, these are some variations. Yes or no? Some mathematical variations. Is this clear? Tell me, is this clear to everyone? Because the question is saying that 128 times more tuples are inserted. So your answer will be this. Correct? This query also they can give. They can do these type of things they can do. Okay, let's see this question quickly. Can you tell me the answer for this? A simple query is given to you, an instance is given to you. So what is the answer? So here the question is saying that where, first of all, you are doing the cross product. First of all, you are doing the cross product. Okay, first of all, you are doing the cross product. The second thing, they must match. So this is a like equijoin. Can you notice this is like a equijoin? Yes or no? Can you notice this is like a equijoin? Agree or not? This is a equijoin, if you notice, because roll number must be equal to roll number. Roll number must be equal to roll number. So this is like a equijoin. Okay, and then finally, you are grouping by name. Okay, so ultimately you are doing the you are doing like this. So this is a equijoin. So you can notice this will match with this and this. These two will match, and this you can notice this will match with only this, and you can finally this will match with this. Okay, so this will happen. Correct? Is this clear? Sorry, that was 2. So this 2 will match with this 2, and you can notice this 3 will match with 3, and this 3 will also match with this. So like this it will happen. Okay, so finally every group has, and you can notice after this cross product is done, this is equivalent. After this cross product is done and this where clause is done, the third step is this. The third step is this, that you will do this. Okay, as name, student name, based on the student name. So how many groups? So there are how many groups? 3 groups. Each 2 tuples. Yes or no? Each containing 2 tuples. Every group will have 2 tuples. So there will be, oh, Raj, name, okay, the name is same. Raj, okay, so there will be two groups. There will be two groups. So in this situation, this is the third step. The third step, this is the step number three, and this was step number 2. And then finally, I can say there will be two groups. There will be two groups because this is also Raj, this is also Raj. So there will be two groups. Okay. And you can notice what will happen. There will be two groups. One group will have Raj and one group will have Rohit. One group will have Raj, one group will have Rohit. Okay, Rohit group, Raj group. Now after that you are finding a student name, comma, sum of marks. Okay, after that you are finding a student name, like how many marks this Raj got, okay, and how many marks this Rohit got. So what is the summation of marks? So the summation of marks, you can notice how many marks the Raj got, that are, those are 80 plus 70 plus 80 plus 80. 80 plus 80. Actually, the question is only asking this. The question is asking number of rows returned by the SQL query. So the answer will be 2. There will be only 2 rows. There will be only 2 rows. And so you don't even have to calculate. You don't even have to calculate. There will be only 2 rows. 75 plus. So there will be only 2 rows. So in the output, there will be 2 rows. Actually, okay, just wait. Actually, this question doesn't need any analysis. I told you this type of questions. Do you remember? I told you this type of questions where you have group by without having. This is your group by. And the question is asking number of rows. So this I told you, if you have group by, okay, if we have group by, and no having clause, if we have group by and no having clause, then number of tuples in the output, what that will be? Number of tuples in output, that will be equal to number of groups. Here you need to take care of what? So number of tuples in the output, that will be equal to number of groups. Here you need to take care after where you, okay, this you do after where. This you do after where clause. After where condition applied. After where condition applied. Okay. So once you apply the where condition, then you have to do this. So after where condition is applied, then you have to do this. So here in this question, you can actually very easily solve this question. So only focus on number of groups. Just focus on the number of groups, how many groups will be there. And you know that at least this matching will happen. Okay. And you can notice at least this matching will happen. And you can notice this matching will happen. Okay. This matching is going to happen. Now you can, for the Raj, this will happen. But anyway, the point is that you will get 2 groups. Okay, yes or no? Because there is no having clause. So you will get basically 2 groups. Here you can stop. Here you can stop. You don't have to care about this select statement. Yes or no? You don't have to care about select statement. The select statement, you don't have to care about it. Is this clear? So this we don't care. This we don't care. Okay, yes or no? The select statement we don't care. You can just stop here. 2 groups means 2 tuples in the output. In the output, there will be 2 tuples. That's it. Because you have 2 groups. Okay, let's see this question. Another similar question. The number of rows returned by the SQL query. Number of rows returned by the SQL query. You have group by clause. There is no having clause. There is no having clause. You have group by clause. First of all, you can notice that P marks should be greater than 84. P marks should be, so this must be done first. This is your first priority. Okay, remember, this is your first priority. So first, what you can do, you can remove those. Like this you can remove, right? P marks must be greater than 84. So this you can remove. This last tuple you can remove. That's it. That's it. That's it. The last tuple you can remove. Okay, so last tuple gone. Last tuple of performance gone. Last tuple of P. Okay, so you can remove that. Actually, what will happen? Actually, you should remove in the cross product. Agree or not? Actually, you should remove in the cross product. So how many tuples will be gone? How many tuples will be removed? How many tuples will be removed? Total 5 tuples will be removed, because for all of them, this tuple will be gone. Okay. For each of them, like this tuple will be gone, 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 this tuple will be gone. So actually 5 tuples will be gone. Okay. But that is similar to this. Yes or no? That is similar to this, that you can remove this first. What we call it? We call it thanks to the early selection. Thanks to the early use of selection. Thanks to the early use of selection. Thanks to the early use of selection. So basically, this will happen thanks to the early use of selection. Okay. Anyway, finally, you can notice that how many groups will be there? You are creating groups by group name. You are creating group by group name. So one group will be created because of this. Group name. Okay. All the names are different. Amit, Priya, all these names are different. There is no other condition. There is no other condition, no other condition, no other condition. Yes or no? Array, there is no other condition in the where clause. In the where clause, there is no other condition. So this pairing will happen. This pairing will happen. Same will happen with Priya. Same will happen with Vinith. Same Rohan. Same Samita. So finally, 5 groups you will get. So 5 tuples you will get. Is this clear? See, there is no other condition. In the where clause, there is only one condition. There is no other condition. There is no equivalence of roll number. You don't have to do any equivalence of roll number, right? You don't have to do any equivalence of roll number. No equality of roll number. So there is no equality of roll number. In the same question, I can create one variation. What is that? I told you that in the from clause, you can put natural join. In the from clause, you can put natural join. So let me put in the from clause, this keyword you can put. In the SQL, this keyword you can put this keyword, that student as natural join performance P. Okay. So if I do this now, this natural join I can put, this keyword I can put. This is a keyword in SQL. Okay. This is a keyword in SQL. So if I put this keyword, this natural join, this is same as relational algebra. Exactly same as relational algebra. Now this is anyway gone. This is anyway gone. Now what will happen? Now this will match with this. This will match with this. Now you can notice, because of Amit, one group will be created. Because of Amit, one group will be created. Because of Priya, one group will be created. Correct? Okay. Because of Priya also, one group will be created. So because of Priya also, one group will be created. Only 2 groups will be created. Only 2 groups will be created. So there will be answer will be 2. Because only 2 groups will be created. Is this clear? In one group, you will have 3 tuples, and in another group, you will have 2 tuples. Okay, so only 2 groups will be created. There is no group for Vinith, Rohan, and Samita. No group. Okay, there is no group for them. There is no group because they are removed in this from comma where. Here they are removed. Okay, Vinith, Rohan, and Samita, they are removed in this. So you can do this natural join. Yes or no? This is another variation possible. Is this clear to everyone? This natural join you can do. Okay. For every tuple. Anyone has any doubt in this? Nikhil, are you asking me any doubt? Let's see this question. What is the doubt? For every tuple, what will happen? For every tuple, sum will be same. The question, look at the question. Sum of P marks. That doesn't matter. That doesn't matter, Nikhil, because the groups are different. You are also taking student name, right? So I don't care about sum. I don't care about sum. Why I don't care about sum? Because you are taking student name also. In the output, you are taking student name also. Yes or no? You are also taking student name. So I don't care about sum. Some can be same, some can be different. I don't care. Yes or no? Is this clear? I do not care about the sum. Let's see this. Let's see this question. Now this is GATE 2009 question, a very simple question. Now this query is given to you. First of all, you tell me, is this query what? Is this nested query? Is this nested query? Clearly this is nested query. Yes, this is nested query. Now you check, is this correlated or simple? Is this correlated or simple? So clearly this is nested query. Clearly this is nested query. This is nested query. Is this simple? See, this is simple, right? This is simple. Agree? This is simple. This is very simple. Now this is also very simple. So I can say this is a nested query, very of simple subquery. Very of simple subquery. So whenever you have simple subquery, then what should happen? What is your analysis approach? What should be your analysis approach? What should be your analysis approach? That should be bottom up. Your analysis approach should be bottom up, right? Correct? Okay. Your bottom up approach. So apply the bottom up approach. Go like this. Go like this. Okay. So first of all, you just find out this, what is this, and you forget about this. First, you tell me what is this, and then you forget about this. First, you tell me what is this. This is giving me non-blue color bots. Non-blue color bots. Okay. So this is basically PID of, sorry, non-color parts. Actually, this is not bot, this is parts. Non-blue color parts. Yes or no? This is the PID of non-blue color parts. The parts which are not blue. Okay. So then finally, what is this? Hello? Yes. So tell me here, what will happen? Here, what you are doing in this? In this, what you are doing? So you are selecting from the catalog. You are selecting SID. You are selecting those suppliers. You are selecting those suppliers. Those suppliers. Okay, those suppliers you are selecting where PID is not in this. So which suppliers you are getting? Which suppliers? So we are getting SID of SIDs we are getting. We are getting SIDs of those suppliers. Those suppliers. Okay. Such that not in this. Okay. The PID is not in this. So SID of those suppliers I will get who supplied blue part. Yes or no? Who supplied blue part. So this will give me SID of those suppliers who supplied some blue part or all blue part. Who supplied some blue part or all blue part. Some blue part or all blue part. Some. Yes or no? Who supplied some blue part. Right? Who supplied some blue part. Okay. Now after this, because remember this is not in. This is not in. Means PID should not be in this. Means PID should not be non-blue. PID. Part ID. PID should not be not blue. PID is not blue. PID is not non-blue. It means PID is blue. It means PID is blue. So it means SID of those suppliers who supplied some blue part. This is what I will get. Okay. After that, what is the next? Okay. After that, ultimately, I am interested in which SID? Ultimately, I am interested in which SID? Which are not here. Yes or no? So those suppliers who supplied some blue part, I don't want them. Yes or no? I don't want those suppliers who supplied some blue part. So I want SID who did not supply any blue part. Yes or no? Who did not supply any blue part. Agree? Yes or no? Because I will, I am not interested in these SID. Okay, I am not interested in these SID. I want those SID which are not here. I want those SID which are not here. I want those SID who did not supply any blue part. Yes or no? Can I say? Who did not supply any blue part. They never supplied the blue part. Is this clear to everyone? They never supplied blue part. Is this clear? Those names I want. Those names I want. So I want those. So ultimately what I'm getting, this query is giving me what? So this query is giving me those who never supplied any blue part. Yes or no? Any blue part. Those who never supplied any blue part. So can I say those who supplied any, never supplied any blue part? Okay. So in this, can I say that those are also there who never supplied anything? Yes or no? Those who never supplied anything, who never supplied anything, who never supplied anything, they are also there. Who never supplied anything, they are also there. Or whatever they supplied, whatever they supplied, whatever they supplied, whatever they ever supplied, what has that? Whatever they ever supplied has a non-blue color. Yes or no? Whatever they ever supplied has non-blue color. Correct or not? Whatever they ever supplied, that has no. So either these people or these people. So what should be the correct answer for this? Let's see one by one. Each option, let's see one by one. So tell me, is this correct answer? Find the names of all suppliers who supplied a non-blue part. Who supplied a non-blue part. So this option also includes that you can also supply blue part. Agree or not? This option does not tell you anything about blue part. So this also includes those people who supplied non-blue and blue. Okay, very simple question I'm asking. Please tell me, if I supplied one red part, one blue part, will I be in this answer? If I supplied one red part, one blue part, will I be in this answer? Yes, I will be. But will I be in this actual answer? Will I be in actual answer? No, I will not be in this answer. Okay, so if I supplied red comma blue, very simple. Okay, this is what I'm saying. Let's assume there is a supplier. Okay, there is a supplier. Okay, let's assume John. This John, he supplied, let's assume blue also. He supplied red also. He supplied blue part also. He supplied red part also. So this John should not be in the answer, right? In the actual answer, John should not be there. Do you agree? In the actual answer, okay, this John should not be there. So let's assume this is your. So maybe some SID. This SID, this is a SID. Okay. And the name is John. The name is John. So definitely in the actual answer, this SID should not be there, right? And let's assume this is the only John. Okay, this is the only John. Okay, just for a moment you assume, because remember, still can John be in the answer? Can John be in the answer still? Can John be in the answer still? Can John be in the answer still? Yes, maybe some other person has John name. Yes or no? Maybe some other person has name John. Maybe some other person. Agree? Some other John can be there. So let me assume this is the only John. Let's assume this is the only person who has John. Only John. Let's assume this is the only John. Okay. Only person with the name John. Let's assume. With the name John. Anyway, you can notice that. So in the actual answer, John should not be there. John should not be there. But in the option A, what will happen? In the option A, what you can say? In the option A, John will be there. Agree? So option A is definitely not correct. Okay, so option A is definitely not correct. What about option B? Find the names of all sellers who have not supplied a non-blue part. Who have not supplied a non-blue part. But they can supply blue part. But they can supply blue part. So actually we want those people who did not supply blue part. If the same question, if this was blue part, then this would be correct answer. Agree? Find the names of who not supplied blue part. Now this would be correct. Okay, so the correct answer would be if you remove this. If you remove this, you will get the correct answer. Okay, so definitely this is not correct. Again, for example, if there is a person, if there is a SID 101, okay, who supplied, let's assume, blue part, who supplied blue part, then definitely in the actual answer, this will not be there. Okay, this SID, let's assume the name is maybe whatever. Okay, Babu Rao. Okay, whatever. So you can notice in the actual answer, this Babu Rao will not be there. Okay, but in the option B, the Babu Rao will be there, right? In the option B, there will be Babu Rao. Okay, so the option B is also not correct. What about option D? Tell me about option D first. Find the names of all suppliers who have not supplied only blue parts. Find the names of those suppliers who have not supplied only blue parts. Who have find the names of all suppliers who have not supplied only blue parts. Who have not supplied only blue parts. See, this person will be in the output or not? In the option D. In the option D, this Babu Rao will be in the output or not? Who have not supplied only blue part. He has only supplied blue part, right? He has only supplied blue part. Okay, for example, this John will be in the answer or not? Just tell me. In the option D, John will be there or not? Did John supply only blue part? Did John supply only blue part? Tell me. Tell me. Did John supply only blue part? Did John supply only blue part? So tell me, in the option D, John will be there or not? In the option D, John will be there or not? He will be there, yes or no? So in the option D, John will be there. But in the actual answer, John is not there. In the actual answer, John is not there. Agree? In actual answer, John is not there. So this option is definitely not correct. So, okay, now let's see option C. It looks like option C is the only answer. But let's see the option C. Is this correct answer? Find the names of those suppliers who have supplied only non-blue parts. So this is correct, right? Yes or no? Actually, here there is some interpretation ambiguity in this option C. In this option C, this is correct. This is correct. Because we want only those people who never supplied blue part. Okay. See, actually option C does not cover this. Option C does not cover this. Agree? Agree, option C does not cover this. Who does not supply anything? Option C does not cover those people who did not supply anything. Is this clear? Option C does not cover those people who did not supply anything. Agree or not? Is this clear? Let me know. Okay, so, but anyway, from the question, option C looks like the best answer. Yes or no? See, this is the only problem. This is the only problem, that these people are not covered. But I think that from the options, you can very easily see option C is the best answer. One more thing. Basically, answer should be, the best answer should be what? The best answer, the best possible answer is this. If I remove this non, and then this will become the best answer, right? Now this will become the best answer. Who did not supply any blue part? Who did not supply any blue part? This will become the best answer. Who did not supply any blue part, right? Is this clear? So who did not supply any blue part? So this will become the best answer. But here one thing I want to tell you. If I did not supply any blue part, not supply any blue part, not supply any blue part, Maybe the question maker was thinking that if you did not supply any blue part, then it means you only supplied non-blue part. Are you getting my point? Yes or no? Are you getting my point? Is this clear? Maybe this was the actually, if you notice, this may be the thinking of many people. This may be the thinking of many people. Agree or not? Not supply any blue part. Not supply any blue part. It simply means only supplied blue, non-blue part. So maybe this was the thinking of question maker. Okay, maybe this was the thinking of question maker thinking. Correct? Maybe this was the thinking of question maker. Maybe this was the thinking of question maker. Okay, this might have been the thinking. Is this clear? Okay. So anyway, from the options, option C is the best. But one thing I can guarantee, what I can guarantee? One thing I can guarantee that the remaining options are not correct. Yes or no? The remaining options have a big problem. Yes or no? The remaining options have a big problem. The remaining options have a big problem. Like this option D has a big problem. You can notice option D, you can clearly see option D has a big problem. Because in the option D, John will be there. In the option D, John will be there. But John will not be there in the actual answer. So option D has a big problem. So definitely you can notice the remaining people are not. Okay, so the answer will be option C. This is the best possible choice. 99.99 actually. I would say 99.99. Because it is only not the question maker. See, not only question maker, but many people will think like this. Yes or no? Many people will think like this. So I can say almost 99.99% this is correct option. Okay. And one more thing I want to tell you, that this question, if you check on the other websites, okay, you can guarantee, one thing you can guarantee, that whatever happens, A, B, D are not correct. Yes or no? Whatever happens, A, B, D are not correct. Okay, this you can guarantee. But if you check this question on the other websites, then there are some websites who have given D as the answer. There are some websites who have given D as the answer. So I suggest you not follow those websites for the GATE exam. For the GATE exam, you should not follow those websites. Is this clear? There are many websites who have given the option D as the answer. And what is the problem with those websites? Let me tell you the problem. The problem with those websites is you cannot put there your input. Are you getting? You can read the file, you can read the answer, but you cannot put your comment. If you cannot put your comment, then if they have done something wrong, that will stay wrong. Agree or not? Because you cannot put your comment. In the GATEOverflow, what is the best thing? In the GATEOverflow website, all the toppers every year, they see the question. Yes or no? So in the GATEOverflow website, for example, if some answer is there and if some mistake is there, small mistake is there, then someone will point out, someone will make a comment. Okay, so that's the benefit of GATEOverflow website. These websites like GATEOverflow, Stake Overflow, Stake Exchange, okay, these websites where the user can give the input, where you can comment, where you can point out the mistake. Okay, so those websites you should follow. Don't follow for the GATE exam. Do not follow, never follow those websites where user cannot give the input, where once if something is wrong, it will stay wrong for a long time. Okay, maybe for 1 year, 2 years, maybe for 10 years, it will stay wrong. So if you cannot give your input, those websites you should not follow, because the very simple point that, remember, one thing is guaranteed in whatever website you take, whether you take GATEOverflow website or whether you take other websites, professor is not going to come to answer. Yes or no? The GATE professor is not going to answer. Who will answer? Who will answer? Some student will answer. Some student will join those websites, those companies, okay, and then they will answer, right? So students can make mistake. So in the GATEOverflow website also, student will answer. Like I will answer, you will answer, some other topper will answer, some previous topper will answer, some Arjun sir will answer. So someone will answer. But there is a benefit. What is the benefit? That you can comment. Your opinion you can comment. My opinion I can comment. Okay, so we can comment our opinion, and then we will see, okay, what is the best, and then we will answer. We will select that answer. But in these websites, in other websites, there is no I can say user interaction. Okay, so those websites you should not follow, because remember, on those websites also students like you and me or some other, okay, they are answering those questions. Okay, so anyway, let's move on now. Let's see this last question. Tell me, this is our last question for this session. So this table is given to you, passenger and reservation, and the question is asking, this query is given to you. First of all, you tell me, is this query what? Is this nested query? First of all, you tell me, is this nested query? Yes, this is a nested query, right? This is a nested query, this is the nested. Okay, is this a correlated query? Is this simple or correlated? This is definitely correlated, right? This is definitely correlated, because from from the outer table you are using PID. So how to do? Okay, here you don't even have to do analysis. We will do analysis after some time, but in this question, do you have to do analysis? In this particular question, do you have to do analysis? No, you just have to apply this on this table, on this table. Okay, so let's apply this. So first of all, you can notice select star. If this was count star, then what would be the answer? Then you don't even have to check. Then you don't even have to check, because that will be always true. If you put count star here, if you put count star here, okay, here if you put count star, then this will always become true. This exist will become always true. This will become always true. Okay, it will always be true. So here you can clearly see this is not a count star, this is selecting the tuples. Okay, so here you can notice, first of all, class must be AC. You only have to check the class AC. First of all, class must be AC. So you can remove this class, you can remove this class. The class must be AC. The output will contain PID. The output will contain PID. This will come in the output. Okay, so the class must be AC. So again, in this question, what I'm saying, that you can clearly see that class must be AC, right? Class must be AC. So you can remove these two tuples. These two tuples are gone because class must be AC. The second point, what should happen, that passenger PID and reservation TID, they must be same. Okay, they must be same. So passenger PID and these, they must be same. So and age must be more than 65. This type of passengers. So you can notice this is like 8. Okay. So, oh, sorry, PID. Okay, the question is checking for PID. Okay. This is correct. Okay, the question is correct. This PID should be equal to this PID. They should be same. So here you can notice that this, so the age should be greater than 65. This type of passenger should be there, where the age is greater than. So definitely this will not come in the output, right? This will not be in the output, right? Yes or no? Definitely this will not be in the output, because this 0 and 0 PID are same, but age is not more than 65. Okay, age is not more than 65. Definitely this will come in the output. This will come in the output. What else? What else? Definitely this will come in the output, because age is more than 65. Next, you can notice that this will also come in the output. This will also come in the output, because like this. So that's it. Only these people will come in the output. So total, how many outputs? So the answer will be 1,3. Number of outputs will be, okay, so what will be the output? That will be, what PIDs are returned? The answer will be option C. The answer will be option C. Correct? So option C will be the answer, 1,3. So this is a simple question. But let's do the complete analysis. So in the analysis, what we need to do, what this query is actually saying. See, this query is saying that from passenger, I need PID. This is a passenger. This is your reservation table. In the reservation table, you have PID, class, TID. Okay, we only care about PID. We only care about PID, right? And we also care about class. We don't care about TID. We don't care about TID, and there is passengers. These are the passengers. For the passenger, what we care about? For the passenger, we care about PID and age. For the passenger, we care about PID and age. So I want those PIDs. Remember, one by one, I want those PIDs. These PIDs I want in the output. So for every PID, I will check where the class must be AC, right? So those PIDs I want where the class is AC, and there should exist a passenger. So for every PID, I will check. Like for example, this PID. Okay, maybe okay for this PID, like whatever PID I take. For this PID, I will check that class must be AC. This must be AC.
Now for this PID, what I will do, I will go to this table. Yes or no? For every PID, you will go to the passenger table. Correct? You will go to the passenger table. So for every PID, you will go to the passenger table, and then you will check. There you will check that for the same PID, what should happen? How many tuples are there? Where how many passengers with this same PID have age greater than 65? Yes or no? Yes or no? So these people where PID must be same and age must be greater than 65. How many tuples are there? This type of tuples should be there. Okay, this type of tuples should exist. This type of tuples should exist. So that's it. So finally your output is what? So we are getting those, your output of this query. What was that? That is those reservation.pids. Reservation.pids. Okay, for which are of AC class. So those reservation.pids we want. Okay, first they have AC class. Have AC class, correct? So they have AC class. First of all, they have AC class. And the second point, there exists at least one passenger. There exists at least one passenger with greater than 65 age for that PID. For that PID, right? Okay, for that reservation.pid. So this is your output. Okay, so you can solve this question. The answer will be 1,3. This is your gate question. So these are enough for this session. Please tell me, did you get all the questions? Each and every gate question, we have done the complete analysis. Did you understand? Did you notice? For every question, what we have done? For every question, like whatever analysis is possible, we have done this. Okay, for every question, whatever analysis is possible, we have done that. Okay, so this is how you should solve the gate questions. Whatever gate question you should solve, okay, you should solve with the complete understanding. Is that clear? With the complete understanding, always solve the gate questions.